In this question, two identical particles of mass m charge q, initially one is placed on a smooth horizontal plane, other is projected along a plane directly towards the first particle from a large distance with a speed v, the distance of closest approach. So the question is like there is a surface, okay, let's say this is the surface here, and on this surface it is said that two identical particles of mass m carrying charge q. So this is a particle here that has a mass of m and that carries a charge q, and this is another particle of mass m that carries a charge q here. Now one is at rest on a smooth horizontal plane and other is projected along the plane directly towards the first particle from a large distance with a speed of v. So this particle is heading towards it with a speed of v. Now what is happening here, the course of the motion, what you will find, because this particle is at rest initially. So in this particle, when it comes closer to this one, this particle when it comes closer to this one, this particle is experiencing retarding force on it, like this way. Okay, it is experiencing retarding force always, and this particle is experiencing also accelerating force on it. So this particle as the time progress is going to gain speed, and this particle as the time progress is going to lose speed. Okay, now the distance between them, what will happen to that distance? So you look here, till if I say that at any moment, let's say at any instant of time, they are moving with the speed v1 and v2. So let's say this is the speed of 1 v1 and this is the speed of v2. So when v1 is lesser than v2, the distance between them will be decreasing. The distance that you see d between them is decreasing. D is decreasing. Okay, and when your v1 equals to v2, in that case the distance between them will be the minimum value. When v1 it becomes equals to v2, in that case the distance between them will be at its minimum value. So d is minimum. And again the distance when v1 becomes greater than v2, then distance between them will start to increase. Okay, so when v1 becomes greater than v2, d is increasing. So at the point of closest approach, I will say that v1 is equals to how much? v2. Okay, so let me redraw the figure here. At a point of closest distance, you will find that they are moving with the same speed. That we can also say using the conservation of we will conserve the momentum to find v1 and v2 here. So this is one, this is another one, and they are moving with the speed, let's say common speed, let's say this is u, or let's say this is v dash and this is v dash. So their speeds are equal right now, and the separation between them is d minimum that we have to calculate here. Okay, so we will use conservation of energy in this case. So I will be writing here by conservation of momentum first. We can write here as m times v plus 0, because another particle is at rest, equals to m v dash plus v dash. So we will get here v dash equals to v by 2. Now by conservation of energy, we can write u initial plus kinetic energy initial equals to u final plus kinetic energy final. So because only electrostatic force is there, so that's a conservative force, so we can conserve the energy in this case. U initially is half mv square, kinetic energy u initially 0, because they are at infinite separation, potential energy is 0. Kinetic energy initially is half mv square, u final is k q square by d minimum that we have to calculate, and this is half mv square by 4 here. Okay, because speed has become double, so half mv square by 4 for one and half mv square by 4 for other one. So if we simplify it, okay, If we simplify this, then we will be getting here the expression that we will get here. This will be half mb square, and on that side mb square by 4. So we will be getting here as mb square by 4. Okay, mb square by 4 should be equals to kq square by d minimum. So d minimum we will get here, d minimum equals to kq square by 4 times kq square 4 kq square by mb square. K can be written as 1 upon 4 pi epsilon naught. So 4 and 4 will cancel there. So the correct option will become 4 q square by 4 pi epsilon naught mb square. So correct option is B.